Hi everyone, today we're going to be doing notes on section 3.2, which is solving systems algebraically. I'm going to go ahead and skip section 3.1 for this unit, which is solving systems by graphing, because based on what I've seen from you so far is you're all able to graph a linear equation, and solving systems by graphing basically just means you graph two straight lines and you look for the dot where they intersect or where they touch, and that's your solution. So we're going to go straight into algebraically. There are two different kinds, substitution and elimination. We're going to talk about substitution first. So go ahead and pause this video and write this down. All right, so substitution. First, what you want to do is solve one of the equations for one of the variables. So in other words, make one of the equations say x equals or y equals. Once you've done that, you're going to substitute that expression from step 1 into the other equation to solve for a variable. Then you'll have either x equals a number or y equals a number. And then once you have that, you'll go on to step 3, which is to plug in the value you just found into either equation to solve for the missing variable. So let's go ahead and look at an example. So when I look at this, neither equation says x equals or y equals, so I need to rewrite one of them. So if I look at this, I think it's going to be the easiest to make my second equation say x equals, because this already just says x. So I'm going to rewrite this as x equals. Now I can either write this as 3 minus 3y or negative 3y plus 3, whichever you prefer. It doesn't matter either way. So I'm going to write it like that. All right, now what I'm going to do now is this whole thing, this value is equal to x, which means I can take this whole thing and plug that in for x in the first equation. So let's go ahead and do that. So I will have 2 times x, which is now the 3 minus 3y, and then the rest is the same. Plus 5y equals negative 5. And then I'm going to solve this. So I can distribute the 2, which gives me 6 minus 6y plus 5y equals negative 5. I have some cleaning up that I can do over here, which will give me 6 minus y equals negative 5. And I want to get the y by itself. So subtract 6 from both sides and get negative y equals negative 11. If you want to show that step of subtracting 6 from both sides, that's fine. And now we want this to be positive y. So I have 2 options. I can either multiply both sides by negative 1 or divide both sides by negative 1. Either way, you will get y equals 11. So now that I have half of my answer, I have my y value, but I still need to find the x value. So this is where it brings us to step 3, where we plug in that value we just found. So I'm going to bring this up here, and we are going to plug in y equals 11 to either equation and solve for x. And it's actually any equation. You could plug it into the first one, the second one, or this one that we rewrote, whichever one you prefer. I'm actually going to plug it into this one that already says x equals that, because I'm solving for x, and x is already isolated. So x equals 3 minus 3y, and I'm going to plug in 11 for y. So x equals 3 minus 33, or in other words, x equals negative 30. Now, when we write our final answer for this, we're going to write it as a coordinate point, as x comma y. So my x is negative 30, my y is 11. And that is my final answer. That's how you'll always write your answers for these systems when you're solving them, x comma y. And then once we get into 3 variable systems, it'll be 3 numbers instead of 2. Let's look at a second example. So if I look at this, step 1 is to solve one of these equations for either variable. The second one, they both have a coefficient, but my first equation, x and y, neither of them have a coefficient. So I can decide if I want to solve this for x or solve it for y to plug into my second equation. It is 100% your choice. Both of them will get you to the same answer. So for the last example, because I got x by itself, this one I will isolate y, just to show that it doesn't matter which variable is isolated. So y equals, now again, you can write this as negative 5 minus x, or you can write it as negative x minus 5. Again, I'm going to write it this way as a contrast to my first example to show that it doesn't matter whether you put the variable you subtracted at the beginning or at the end. So now I know that y equals all that. So I can take that and plug it in to my other equation where I see the y. Oops, sorry. So let's go ahead and do that. So 4x minus 5 times y, which is now all this stuff, which is negative x minus 5, equals negative 20. Yeah, you should have said distribute. So now I have 4x plus 5x plus 25 equals negative 20. Now, if you wanted to do this all in one step and write 9x equals negative 45, you can do that all in one step. Or if you're more comfortable with doing it in 2 separate steps, I will show it written out that way. Oops, that's 25, not 2x. Yeah, let me erase that real quick. Oh my gosh, where'd my eraser go? There it is. That should be 25. Equals negative 20. So 9x equals negative 45. So x equals negative 5. All right, now I've successfully solved for one of my variables, but I still need to find the other one. So I'm going to plug x equals negative 5 into any equation and solve for y. So again, you can plug it into the first equation, second equation, or the one that I rewrote. Because I'm solving for y and this one already has y isolated, I'm going to plug it into that one. So y equals negative x minus 5. So y equals negative 5. Make sure you're careful with those negative signs. So y equals 5 minus 5, which is 0. So my final answer is negative 5, comma 0, because we write it as a coordinate point. And there we go. Those are examples that we're going to do for substitution, but let's go ahead and move on and do elimination. Now let's look at solving systems using the other method called elimination. So step 1, make sure that both equations are in this form, ax plus by equals c. A, b, and c are just coefficients, which is a fancy way of saying they're numbers. So basically make sure that x and y are lined up and it's equal to a constant. Once you've done that, step 2, you're going to multiply one or both equations by a constant to get coefficients that are opposites. For example, 2 and negative 2, 7 and negative 7, 4 and negative 4. Because then when you go to step 3 and you add the equations together, it's going to eliminate that variable because they're opposites. They'll cancel out. Once you've done that, you'll get an answer that says either x equals or y equals, and you'll move on to step 4, which is just like substitution. You plug that variable back in to find your other missing variable. So let's go ahead and look at an example. So if I look at this, do you already have x's or y's that have opposite coefficients? Good, you should have said yes. Your y variables are already opposites, 8y and negative 8y. So I'm going to make that little note. Y is already opposites, which means I can go ahead and just add these two equations together and my y's will cancel out. All right, so I'm just going to draw a line to represent adding these together. You can put the little plus sign if you want. I usually don't, but I'll put it for this example. So negative 2x plus 5x gives me 3x. My 8y and negative 8y cancel, equals negative 8 plus 20, which is 12. Divide both sides by 3, and we get x equals 4. That was pretty easy. We didn't have to multiply anything, and it was super easy to get my x. Now I'm going to solve for y. So again, you're plugging it into either equation. It doesn't matter which one. Both of these have positives and negatives about plugging it in. If you plug it into the first equation, your numbers are smaller, but you're dealing with negative signs. If you plug it into the second equation, your numbers are a little bit bigger, but you don't have as many negatives. So it's completely up to you which one you want to plug it into. I personally prefer to work with positives whenever possible, so I'm going to go ahead and plug it into the second one, just because it's a little bit less likely to make a mistake with the negative signs. So I plug in 4 for x. So I get 20 minus 8y equals 20. Subtract 20 from both sides and get 8y equals 0. So y equals 0. And we write our final answer as a coordinate point, which is 4, 0. And there we go. Let's look at another example now. So if I look at this, my x's and my y's, none of them are opposites already. So I can't go ahead and just add them together like the last example. I have 3x and x, so I can either make this bottom one a negative 3, or my y's, I have a negative y and a positive 2y. I can make this top one a negative 2y. So you have two different options here. The great thing about these problems is there's more than one way to do them. So you may do it differently than how I do it or how someone else in class does it, but you should still end up with the same answer at the end. So I can either multiply the bottom equation by negative 3 to make the x terms opposites, or I can multiply the top equation by positive 2 to make my y terms opposites. Again, I prefer to multiply by positive numbers whenever possible. So I'm going to multiply the top equation by 2. So when I do this, let's see, where do I want to write this? I'm going to rewrite it down here. So I'm going to have 6x minus 2y equals 16. That's my top equation multiplied. And then my second equation stays exactly the same. I didn't do anything to it. Oops, what just happened to my document camera? Sorry about that. All right. So now I can go ahead and add these together. My y terms are going to cancel out. So I end up with 7x, the y's cancel out, equals 21. Divide both sides by 7, and we get x equals 3. So I now have half of my solution. But I still need to find the y value. So I'm going to solve for y. Now again, you can plug this into any of the equations, your original first or second equation, or the first equation that was multiplied. You can plug that value back into any of those three equations and you will get the correct answer. It doesn't matter which one. I'm going to choose to plug it into the second original equation because it has the smallest numbers. So I'm going to plug it into the x plus 2y equals 5. So my x value is 3. Subtract 3 from both sides, and then divide both sides by 2. Oops. I was saying 2 out loud, but I meant to write 1. So y equals 1, which means my final solution is 3, 1. Let's look at one more example for elimination. So if I look at this, my x terms, they are not opposites, and I would have to multiply both equations by something to eliminate the x. Let's check the y's. They are not opposites, and again, I would have to multiply both equations by something to eliminate the y's. So, since I'm going to have to multiply both equations by something no matter what, now I'm going to choose which one I want to eliminate. So I can either multiply the x's, the smallest number that 3 and 5 both go into is 15. So I'd have to multiply the top by 5 and the bottom by 3 and make one of those negative. For the y's, the smallest number that these both go into is 14. So I'd have to multiply the top equation by 2 and the bottom equation by 7 and make one of those negative. You can decide which one you prefer to do, if you want to multiply and get rid of the x's, or if you want to get rid of the y's. I'm going to choose to get rid of the y's. So if I get rid of the y's, I have to multiply the top equation by 2 and the bottom equation by 7. But that'll make these both positive 14, which means one of these needs to be a negative number, and I can pick which one. I'm going to choose to make the 7 negative. If you made the 2 negative instead, you would still get the exact same answer. All right, so let's go ahead and rewrite this. So I'm going to write it down here on this next line. So 2 times this whole top equation is 6x plus 14y equals 30. Negative 7 times the bottom equation is negative 35x minus 14y equals positive 28. My y's will cancel out, which is good. That's what I wanted. My x terms will become negative 29x equals 58. And when I divide both sides by negative 29, I get x is equal to negative 2. Now I'm going to use that x equals negative 2 to solve for y. Now I have 4 options of what equation I could plug it back into. Either of my 2 original equations or either of the 2 equations that I multiplied or got from multiplying. Your choice. I'm going to choose to plug it into the second original equation, the 5x plus 2y equals negative 4. Now you don't need to write this showing which equation you're plugging it into. I'm just doing that for the sake of you being able to look at the notes and know which equation I plugged it into. All right, so I'm going to plug in negative 2 for x. So 5 times negative 2 plus 2y equals negative 4. So negative 10 plus 2y equals negative 4. Add 10 to both sides, and I get 2y equals 6. And then divide both sides by 2. So I get y equals 3. So my final answer is negative 2, 3. Oops, let me make that a little bit more clear. There we go. So negative 2, 3 is my final answer. Now again, the big important thing that I want to stress with these is there is so much flexibility with you choosing what route you want to go through with solving these. You have the choice of which variable to eliminate. You have the choice of which one of these to make negative. You have the choice of which equation to plug this back into. So when you look at the solutions that I do for these, you're just looking to make sure your final answer matches, because your process that you went through for solving these may be different than what I chose to do or what other classmates chose to do. That is the end of our notes. Have a good rest of your day.